Okay, let's get started. So, very warm welcome back, everybody, to the security stream for the GSE virtual conference. My name's Jamie Pease. I'm the chair of the security working group for here in the GSE UK region. And yes, we're getting through the agenda very, very quickly. So I can't believe we've already done 3 sessions this morning on the security stream. And we've got, of course, that continues into this afternoon. Just as a quick recap, don't forget to do your feedback if you haven't done it already. Be very, very grateful. So our next session, it gives me great pleasure to welcome Paul. Paul, please don't ask me to pronounce your name. I'm terrible sometimes with pronouncing people's names. But Paul is from New Era Software, and Paul, I think, was it last year, Paul, you came to present to us on one of our security meetings. So welcome back, and you're going to talk to us about the ABCs of pervasive encryption. And by the way, folks, there is, if you're interested in cryptography, Isha Powers, just a heads up, she's with us tomorrow afternoon to give 2 sessions on crypto. So if you can join us for that would be great. And Paul, without further ado, over to you, sir. Thank you.
Okay, well, thank you very much, Jamie, and thanks very much for the opportunity, and I really appreciate you sharing your platform. Welcome, everyone. As Jamie mentioned, my name is Paul Robichaux, and I am with New Era Software. I'm coming to you from a small town about 30 miles from the center of Silicon Valley called San Martin. And if you've tracked the weather that's going on in California, we believe our drought might be broken because we've had a tremendous amount of rain from atmospheric rivers coming in through the Pacific Ocean since the 1st of January, and we continue to expect more in the next months ahead. I noticed in the agenda that there was several new sessions that were added that dealt with things like modernization and visualization and onboarding of the next generation of mainframe system programmers. And so I sort of adapted this presentation, which generally focuses exclusively on pervasive encryption, to incorporate some of those thoughts so that I could be more in sync with what I think is the rest of the agenda that you'll be listening to for the next couple of hours or days. The general area of pervasive encryption is extremely complex. It involves concepts like key management. Once you do encrypt something, you have a key. What do you do with it? How do you archive it? How do you update it? There's just a whole number of different things that go on there that ultimately, in my opinion, scare people from even wanting to begin the process of pervasively encrypting, for example, data when it's at rest. And we know from surveys that have been conducted by organizations like Bob Hansel's consulting organization here in the United States, that the uptake on pervasive encryption, particularly using ICSF and the CKDS, is not very high. It's in the low teens, and there is little planning or long-term interest in migrating to it. So, and there are other alternatives, device encryption, et cetera, but just to set the stage a bit here, it's not as if everybody on the planet has decided that pervasive encryption is the way to go, at least as it relates to data at rest. There are really 3 domains of involvement here: network administration, storage administration, security administration, all of which have to come together in a cooperative way in order to appropriately establish pervasive encryption. In some cases, as it relates to the establishment of a security association between a client and a server, obviously digital certificates and the chain of trust are really critical and certainly a part of network administration. as it relates to data set encryption, which we'll spend some time talking about today. Symmetric encryption involves being at certain levels of data set management generally within your organization, particularly data sets that have extended format. And that involves relationships with storage administrators. In both cases, whether it's digital certificates and security associations or data sets, at the end of the day, we're all going to have to pass through security administration. And when we do that, we're not only dealing with the CKDS and its constituent partners, the PKDS and TKDS, but we are also dealing with the fundamental classes that exist in RACF or ACF2 and the profiles and permits that are related to them. And so by this time, you probably understand that there are a lot of moving parts here, and any one of them can break the chain of trust, if you would, between our security goals and the actual production that is so important to us on a day-to-day basis. In addition to that, once we've established these controls, we've established a key, we're actually going to have to apply it. And in the case of data set encryption, that means that to the data set profile itself that's in RACF or ACF2, we're going to have to augment it with a segment that we refer to as a DFP segment, and actually insert the key in the data set profile itself. And then finally, we're going to have to permit someone to actually use that. So there are a lot of parts here that all have to work together. Not to overstate it, but it's complicated. And it's certainly, in my opinion, at least, one of the reasons why the uptake of it has been slow. It's been out for probably 10 years now at this point, and again, in the low teens in terms of uptake, at least in the United States. Our goal at New Era is to invest our time and energy and treasure in the establishment of methodologies that allow us to easily navigate these policy decision points and enforcement points within your environment. As the Nobel laureate Thomas Mann stated, the first step towards the mastering of any subject, particularly if you're a newbie getting into this for the first time, is to seek order and simplification, not dwell on the complication, but to try to order things out and simplify them in such a way as to make it clearly understandable. Another echo to the issue of transitioning from a prior generation of system programmers to a new generation of system programmers can be found in Nicholas Carr's work, which is referred to as the Shallows. Nicholas Carr is a Pulitzer author. He was clearly recognized for this going back almost 15 years now at this point, when he discussed with us in detail what the internet is doing to our brains. It emphasizes the difficulty of making the transition to the next generation of any generation of anyone who will move on to take the place of a prior generation. Generally, what it says, to sum it up, is that the older generation generally looks at the new generation as being shallow. And what they mean by that is that we've adapted to new technologies and new methods of doing things that don't require us to know in detail what the older generation knows. And therefore, when they look at us, they think of us as being shallow in terms of our knowledge, because we don't understand things in the same way that they do. And the reverse is true. We learn as a new generation new things. You only have to go to an airport and look at someone thumbing through their phone and realize that they're probably 30 or 35 years old or less than that. And then look around and find somebody who's older, who's sitting around reading a newspaper or a magazine. There is a difference that's going on, and the transition that is forced on us by technology speeds it up, and it makes it difficult for us to move on and not give up what we've learned as legacy system programmers like myself as we approach, excuse me, trying to onboard that next generation. Today, we're going to focus on cryptographic data set key issues, and we're going to primarily look at seven different things. You can see them laid out here. We're going to add a key. We're going to profile a key. We're going to add a permit. We're going to do a whole bunch of different things that are necessary in order to accomplish establishing an appropriate key to protect a specific data set or a class of data sets that might be defined generically. In order to do that and to illustrate the point, we're going to use two specific different interfaces. One is the classic 3270 interface that here is shown as the ICSF token panel showing the token detail. Now, this is a panel out of ICSF, the ICSF interface. And in addition to that, we would also normally get into TSO commands and RACF panels and RACF commands, but we don't have time for that today. And my partner, who normally does this presentation with me, Jim Lautner, is not available. So I'm going to do that, just a bit of that to give you a flavor for it. And then we're going to jump into ICE Direct, which is a visual experience within zOS that attempts to do two things. Number one, it converges data. It takes data from many different sources, ICSF and RACF and zOS, and converges them together in a picture that's similar to what you see to the right. And it does it in a visual way, in a way that draws you in, gives you confidence that what you need to further understand it is at the click of a mouse, and allows you to drill down into the lowest level of detail, and allows you to, continuously repeat that experience if in fact you need to. So what we would normally do if this was my part right now and Jim had done his, was we'd launch directly into that. But what I'm going to do is cancel this session for just a moment. So I'm going to get out of this. And I'm going to fire up a 3270 session. And I hope we're able to see this. Kind of widen my screen here a little bit so we can see this more appropriately. And I'm going to go ahead and log on to TSO. Oop. Wow, great. Wrong password. Well, shame on me. I'm not sure what I did wrong there, but I hope you'll forgive me for that. Actually, I pray you forgive me for that.
We forgive you, Paul.
Oh, thank you very much, Jamie. I don't know how I could forget it. It's my dog. I don't know. She will probably come and find me and chastise me for being so bad. Okay, so here we are. We're at the ready prompt. I'm going to type in ISPF. You guys have probably done this 1 million times in your life, or 2 million times. And at the command line, because we're going to ICSF, ours is set up to reach the interface essentially by typing in TSO ICSF run. That's our application name. And so here we are at the ICSF primary menu, Integrated Cryptographic Service Facility. Now, there are a whole bunch of options here, and I don't want to set any expectation that what you're going to see in ICE Direct will do all of this. That's not the name of our game. What we're most interested in are the things that would be done commonly, repeatedly, by someone who is not going to take responsibility for setting up the master keys, setting up CPAC-F, all of those things. This is a user. This is someone who is in the process of managing the keys themselves, setting up new keys, changing the characteristics of keys, interested in the metadata and the other attributes of the keys. That's what this particular interface is really all about. Now, if I select option number 5 here, the utilities option, we'll see that there are the 3 specific data stores within ICSF, key stores, the CKDS, PKDS, and CS11 token data stores. And we can deal with all 3 of those, but today we're going to deal with number 5 here. So the CKDS. And we get a panel, obviously, and we can list all the records, and we can do other things here if we choose to do it. So I'll go ahead and select option number 1. And in some ways, ICSF follows the same rubric that we do here at New Era. Whenever we present information about a topical issue, we always take inventory of it so that we can present the gestalt of it, that is, all of them, and analyze them and show the characteristics of them. And ICSF is doing that. It's showing us a list of all of the key labels that are in it. And here's the list. And to the right of that, we can see the key types. So there's 2 different key types. There's a cipher key and a data key. And my colleague and associate and shall we say mentor in this, Greg Boyd, would tell you that cipher keys are better than data keys, and he knows the details about that certainly much more than I do. But just stated up front, the cipher key seems to be a better option. The only problem with that is that in ICSF, you can't make a cipher key. You can make a data key, but you can't make a cipher key. Now, there are methods that you can use, and Alicia actually has out on the web, and I'll share that with you in a little bit, a Rex program that you can adapt and create cipher keys with, but you cannot do it directly from inside of this interface. Now, once we're in here, we have a number of options that we can take. So we can take the M option if we want to, and we can drill down into some specific information about this particular key label. There's really 2 kinds of information. There's attributes, and then there's metadata. And down here in the lower section of the panel, we can see some of the metadata. So when was it created? When was it updated? We can't change that. That's all under the control of ICSF and CPAC-F. The cryptographic start date, the end date, when it was used, we can change that if we want to. And then if we page down a little bit, we can change things like whether or not we want this particular key to be archived. And if we run it up and say, okay, let's archive it, from the perspective of some data sets that are encrypted already, their use will be directly impacted. They will appear to the system as having been cryptographically erased. So setting something up to be archived is not a particularly good thing. And there's a flag here that can prevent that from happening. But there's also methods within RACF profiles, for example, the facilities class as an example, or exfil classes, that can be brought to bear on whether or not an archived label could be used under certain circumstances, either for decryption, not for encryption, but for decryption, or could be used for both. And again, we're back to that conundrum of what do we want to really accomplish? Well, what we really want to accomplish is ongoing production. And quite often that takes precedent over ongoing integrity and security, but it's an issue. And that can be all managed from here. This is not the particular problem. And then you can, you can do your normal thing. You can scroll up and scroll down here if you choose to want to do that. And you can see that there are other characteristics here. Go back. I believe we have another one here, which is, I think it's K, I think. Yeah, and this gives us more information. This is attributes and metadata combined together. Jim's the expert on this, not so much. But you can see all the data that's here, and you can see it little by little down in the bottom of the panel. And if you're into this, and this is what you do, you're probably used to this. And these little snippets that you're seeing now could quite likely lead you to a better understanding of what this particular label is all about. Now, if we go back and we get to this point and we say, let's generate a key, it's relatively simple to do. All you do is you enter some key label. And you pick a key size. Now, the bigger the key, the better. And we'll talk about that in just a little bit more when we get into the website of this, because there are some changes in 2.5 that lengthen the possible size of the keys that are in the CKDS itself to 37K or something like that, some really large number. Okay, so the key was generated. So now we could go find the key. And we'll list it. And it must be down here somewhere. Okay, so there it is down at the bottom, some key. And you can see that by default, it is a data key. And if we chose to, we could take a look at it and get some better understanding of what's going on. But trust me now, we're just getting started. We just have a key. Now we got to go protect the key. Now we got to go apply the key. Now we got to go agree whether or not we're going to prohibit archiving of this key. All of these things are going to come into play here now as we move forward. Okay, so that brings me to the end of my use of a 3270 environment. And so what I'm going to do now is I'm going to go back to my PowerPoint, and we are about to enter the web. Now, there are a lot of different ways in which web applications can be deployed and used. But in the case of a zOS environment, the tool that we have available to us, which is the preferred path, is zOSMF. The reason for that is because you're going to wind up using it anyway. You don't really have any choice at this point. And you will likely know the level of security that surrounds zOSMF, the various profiles and permits and this and that and what have you. And so this is our recommended path, not to use ICE Direct directly from the web, but in fact to use it through zOSMF. Now, in order to hit ICE Direct on no matter how you attempt to get there, you're going to need a valid socket. So you're going to need to know an IP address and a port in order to do it. That's one level of security up as a result of your firewall providing some protection for you. But this is a better way, and this is a recommended way. So if I click on log on to zOSMF, I've already been in here this morning, so it says, okay, well, I know you're here. Your session hasn't timed out. We'll bring you back again. What you see on the screen is what you see in a 2.5 environment, which is the environment that I'm in. But there is also another way of looking at things, which is the 2.4 method. And I tend to like it better. It's what I was used to, and it's what I use for explaining the connections. The way in which we tie ICE Direct to zOSMF is by defining a link. And a link is an attribute of zOSMF that can be SAF protected if you choose to do that. Setting it up is relatively easy. It can be done through the administrative panels in zOSMF directly. You can set up as many of them as you want, and some of our users have 2, 3, 4 different links to different zOS systems around the world. And so from one central point, they're able to access ICE Direct and its functionality as it services systems in Argentina or in China or in Europe or somewhere else, as the case may be. If I click on ICE Direct here, what happens is that we launch another tab. And in that tab, I should say, zOSMF launches another tab and calls the socket that was programmed into that link. Now, the socket is referring to an IP address that is on some other server, not the one that zOSMF is on, but on another server. So I'm going to go ahead and log on to that. I have to re-authenticate with this zOSMF, with this zOS. And when I do, I get another authorization or authentication panel. This is one where what we're going to have to enter now is a pass ticket. And that pass ticket is made up of 2 different elements. One is a prefix that I have registered with the ICE Direct environment. And the other one is a token or token material that was created by the pass ticket generator of the external security manager. And we chose at random some characters from it in order to produce it on the screen, so that now we have both the prefix, my prefix, and the token material now bound together in a complete password. So I'll go ahead and click that. Oops, sorry, I clicked too soon. Try that again. Zoom sometimes gets in the way, and I couldn't see that the system was working. So I should move this down just a tad. Thank you. Okay. So what you see on the screen now is a frame set. These are sandboxed. They can only talk to the server, or the server can only talk to them. There's a whole bunch of security stuff that's behind here. We have a content security policy that protects the interaction between your browser and the zOS server that's serving up the web pages that you're about to see. The frames are on the left, what we call the sidebar. That applies specifically to new era applications like image focus in the control editor. The crossbar, which you obviously see across the middle of the other 2 frames, houses a link which is called the visual application stack. And that's where we're headed. We're not going to use new era specific tools. We're going to use some other tools which are in our stack. They include access to applications named zOS Virtual. This is all about zOS, what's on, what jobs are running, and which ones have active IP connections, what is the relationship between the IP connections and the server, et cetera, et cetera. RACF Visual, that's about RACF classes and servicing the RACF community. RACD Visual is all about certificates and key rings. And Client Visual, which I'll hopefully be able to come back and talk to you about later this summer, is a very interesting application, excuse me, that gives you an opportunity to evaluate the connectiveness of the server, or excuse me, the client, which in this case is zOS, to any remote server that you might have out there that you would like to connect to, and you might be having problems connecting to. This guy will show you what you're doing wrong. We're going to go to ICSF Visual. ICSF Visual supports all of the data stores within ICSF, the public key data set, the token data set, and of course the functions of data set encryption, or CKDS. So I'm going to go ahead and click that. Now, again, in accordance to our rubric, that is how we do things at New Era, much like ICSF, the first thing we're going to do is take inventory. But it's going to take us a little bit longer to complete our inventory, because while we're taking it, the second part of our rubric says evaluate it for any issues that might exist within it. So, for example, let's look to see if any of the labels may have expired. Let's look to see if any of them are going to expire shortly. Let's look to see if they might be archived, or whether they're prohibited, or whatever. So not only list them out, but to evaluate them at the same time. Now, as you look at the panel, you also see some additional information, which we believe turns this into a compliance document. Up at the top is specific information about RACF, the release level, what authority I have, special auditor in this case. When was the system last IPL'd? What are the IPL characteristics of it? What kind of RACF do we have? We can see here that we're running one that is a vSAM cluster. Right now, because it's a development system, we don't have a profile and we don't have a UACC, but if we did, we would fill that information in. The subheader that's down below that shows us some characteristics of ICSF. For example, how many labels are in it? What's the name of the data set? What format is it in? KDSR or KDSRL is the recommended format for any of ICSF's data stores. KDSR format allows you to get attribute information and meta information. Without it, you can't get it. So you would be flying blind by this point in time, and you'd also be flying blind inside of ICSF as well, as it came to other information that you might be interested in. There's other things that you might be interested in as well, which has to do with how ICSF and CPAC-F are set up. So if we click on more detail, again, you might not use this every moment of every day, right? But if you had to get to it, knowing that there was a path that could allow you to see in a moment whether CPAC-F was up and functional, that is, it's enabled, and all of the characteristics that are associated with it that might reveal some issue to you can be revealed by just simply a mouse click. So that's what that was essentially all about. We have some other functions up here at the head. Dataset profile key cross-reference, we'll show you that in just a minute. One that people do find interesting is to go and pluck out from the health checker all of those that apply to ICSF, and to present those in a way that allows you to drill down into the information that is provided by the health checker relative to ICSF. So if there's a problem, a key's expiring, about to expire, anything that you might think of, then those things that are reported by the health checker are reported here. We mentioned that when we started this off, that there's a lot of things that are associated with a key label that deal with other entities, like RACF and a RACF profile, and several of those. And we can see the characteristics of those if we were to, for example, click on link. So for a given key label, the panel was showing us when it was created, its create date, when it was last used, when it's going to start, when it's going to expire, et cetera, et cetera. But now we're going down to another level of information here. And what we are actually doing is now taking a look at all of those other entities that will impact whether or not this particular key label can be used for data set encryption at all. One of the profiles in your external security manager, which can enable or disable certain characteristics of the enforcement of the label is in the facilities class, and it's called stag admin SMF fail valid blah blah blah. Something worth getting familiar with, but just simply let me just sum it up. If the data set that you're attempting to allocate is not an extended format, but it does have a key label associated with it, this can determine whether or not it will be allocated at all, might be rejected, or it can make a decision based on how you permit it to actually go ahead with the allocation, but to do it and put data in it in clear key. So there's some characteristics here, I think, that could best be summed up as let's not let the production fail just because we fail to have an extended attribute data set. Then there are two other ones here that are important. One that deals with the archiving of the key itself. And if the key label happens to be archived, and all of a sudden, a month later, we decide that we need to get to that data, then this profile will allow us to get to that data by saying, yeah, okay, well, it's archived, but, for purposes of continuing production, we can set this up to allow it to decrypt the data and then allow us to use it. Or we can have another that would allow us to do it both ways, that even though it is archived, we can use the key for both encryption as well as decryption. So these are all there. There are certain things that we can do here. So for example, if we want to permit something to that facilities class profile, we can do it here. So we could enter a user ID or task ID, give it some characteristic like none, and go ahead and proceed and add it. We could delete it here too. We could delete that profile altogether if we chose to do that. And we can do that continuously. We could set up a profile because we don't have one set up. That's what the thumbs down was all about. We can go ahead and set that profile up. We could give it a UACC. We can record some control information that we refer to as a descriptor about why we're doing this. That would be recorded in our journaling system. But down below that now, below these in the facilities class and the exfil class, we can now see some things that might be really important, and we're trying to present them as standouts in the presentation itself. The first one is the key label itself has certain characteristics about it when it's going to cease to work. Well, this one's going to cease to work on April of 15. And so that's 60 days from now. And so we've highlighted that in this sort of lavender color here to say, hey, you want to pay attention to this. And next to it, it tells us in red that the archive bit is on. And oh my goodness, well, maybe we don't intend that to be that way, but it's good to know. And we'll show you how to take care of that here in just a moment. And then we have a profile that's protecting this key specifically, and it's called the CSF keys profile. And that profile is set with CPAC wrap no and CPAC wrap yes. And we can permit people to it if we want to. It's a live profile. But if it's set no, it's going to fail. And not only is it going to fail here, but since this profile can also be used for PKDS protection as well, it's likely that even though we might find CPAC wrap no there as well, it's not going to have the impact that it's going to have here. So let's go change that. Oh, click the wrong button. More detail here. Let me click the right button. So we can see here now that we have a panel that repeats what we saw earlier. It tells us what command we're going to use, what class it's in, what the profile name is. We didn't enter any of this. We haven't touched the keyboard yet since we've been here, except when we're on the 3270 side. We're going to set this to yes, because that's the preferred way to do it. We'll leave it set at none, and we'll click this. And now we can see that what we attempted to do, which is this, has been accomplished. We didn't get any reply from RACF, which is notorious for not replying to anything. Now, if we chose to, we could redisplay the cross-reference. So here we are back where we started, and you can see now that CPAC wrap is set to yes, and so we don't have any red issues here for us to deal with. If we look a little bit further down the panel, we can see that there is a data set profile that is using this particular key, and we can see the data sets that are probably affected by this particular key. And we can see there's a ton of them here that are impacted. We could click on dataset profile here. By the way, I'm not claiming that there isn't a learning curve for this as well, but it's structured in such a way as to provide as best it can the information that's needed at the moment at which it's needed. And so here are the various data sets. I believe that all of these are sequential in nature, but if they weren't and you clicked on them, and I don't know if there are any in here right off the top of my head, maybe this one might come back and tell us it's yeah, okay, so here's the data set itself, here's its content. So we can review it, see it, do what needs to be done with it. What we're attempting to do here is not leave you hanging, not leave you in a position where you say, oh, well, that's nice, but if I only had. What we were trying to do is to present that what we've got when you need it kind of view of the world. We can always back up in this, by the way. The backup button will remember what we've done. We do have a content security policy that manages the browser's retention of information, and you can set that as restrictively as you choose to. If you don't need a backup button, then don't do one. We mentioned that we can add a key here, or a label, excuse me, a key label. And we can choose, select the kind that we want to. So remember, we said we could only do a data key on the 3270 side, and we could use a Rex program to straighten it out. Here we can create a cipher key. We can give it a label. We have a format that we recommend. Give it a qualifier, and I will give it AAA, so it sorts at the top. 1, 2, 3, 4. Give it a name. Usually this is a data set name, but we're not that strict at this moment. So this one's for me. We could have a qualifier called encrypt key. We'll leave that there, and we could give it a sequence number if we wanted to. And you may have your own format. This is not restricting you in any way, okay? The only thing that's required here is the 4 qualifiers. You want to use them to appropriately define the key, so that when we do our inventory and you look for it in the list, you can find it automatically. Now, when we go to the next step, this is always a step in IceDirect. We call it the validation step. This is where you look and see, yes, that's what I want to do. You can see over here, it says Rex source. If I click that link, I'll go to the source of the Rex program that we are using in order to create that key. It's out in the public domain, and you can get to it just as easily as I can. If you want the link, at the end, I'll give you my email address. You can send me an email, and I'll send you the link, and you can go forward from there. If we choose to, we say, yeah, okay, I'm looking at that. That all looks great. By the way, normally, this would be some sort of RACF command. you could just simply copy it, drop it into option 6 under TSO, and it would execute equally well. So it's a kind of learning process as well to teach you how to get the information that you're actually interested in looking for. Again, so this was added. Again, you can get to the recs. We can redisplay the label overview, or we could show the CKDS label record. And here's that label record now at this point that we just added. You can see the name up here at the top. We could delete it now. We say, no, 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 we don't want that. We could delete it. We could say, oh, no, 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 no. I need to give this a stop date. Okay, well, let's give it a stop date. So we'll do that. Okay, so we don't want to touch archive. We're not into that. We don't need to update last use. We're just going to tell it when we want it to stop. So the year 23, we'll stop it in a month, 03, and we'll set it to the 15th. April 15th, that's tax day here in the United States. For those of you that don't know, this is the day we all dread, so might as well use it. Give it a positive pop. Okay, so here we are. We can show the label record again. And we can see it's highlighted because it's going to reach its terminus date within 60 days. Okay, we could delete it, we could fix it, we could do whatever we want with it at this particular point in time. Okay, so we're back and we had another option here. Redisplay the KDS key label overview. Let's redisplay it. Again, we're taking inventory, we're evaluating the inventory. Everything is done essentially in real time. Okay, so here's the label that we just set up, and so let's go apply it. We said we had to apply it, so let's go set a DFP segment. In order to set the DFP segment, we need to know what data set profiles we have. Which one are we going to apply it to? Well, of course, I could remember all of those off the top of my head. Maybe I could have at one point. I can't today. If I look down here, now we see all the data set profiles, those that are discrete and those that are generic. And if we scroll down to the bottom here, we can see those that have DFP segments. They're and they're valid. We can see those highlighted in green. And we can see DFP segments that have labels, but they're not valid. They, for whatever reason, have expired, or they're archived, or this or that, or whatever. So from here, you could take appropriate action to do something if you wanted to. I'll pick on my advisor, Mr. Greg Boyd here, and I'll go and add this particular label as a segment within that particular profile. So you can see the command here that's going to be issued, an Alt-DSN command in RACF against the profile gboyd, and then we're going to add a DFP segment. We don't have to touch any of the other stuff that's in this profile. All we're doing is we're adding this DFP segment. We'll go ahead and add it. Of course, we get to confirm it. And so now we're back, and we can now choose two paths. We can either redisplay the label overview, or we can redisplay the data set profile. We'll do the data set profile. Again, our rubric is take inventory. So we're taking inventory of all the data set profiles in real time. We don't know, you don't know whether something hasn't been added. So now we're down here where we were before, and we're looking at gboyd, And here it is, and it says, yes, there's a DFP segment. It appears to be valid. And here's the key that is protecting that. If we clicked on Greg, we could now go and make a decision as to who or what we wanted to permit to it. Right now, you can see that in the case of this profile, there isn't anyone actually permitted to it. Now, I'm just backing up because I want to show you one more thing before I let you go. Oops, went one too far. There is another aspect of this that's, again, part of our rubric, which is baseline the inventory. And so here is what the baseline would look like. This is a personal baseline. It applies just to you. You have your own. It's a blockchain. Each of the key labels is containerized. There is a token that is created for that container. Each container is linked together so that at the end of the day, we have an overall document token. That's this guy down here. This assures you that no one's messing with your view of the world. If there was messing going on, then when you clicked check for changes, it would come back and say somebody's been messing with your world, and you need to take heed accordingly. And you can see there's a whole bunch of things that have been going on here, including the addition of the key label that I added, which is now shown as an addition. But we can also take a look at changes that might have happened between two key labels. And you can see that we use a technique we call side-by-side compare. And so we can see what's in the snapshot that's within the baseline that we took, that's to the left. And we can see what's in the key store like now. Okay, this is what's there now. And then the differences are highlighted so that you can tell, okay, well, you know, the last time it was updated, that changed. The stop date has changed. That's particularly important. We could, if we chose to do it, we could exclude the update date from our comparison. One final thing, let me click on this. Now you said, well, you take inventory, but can you show me the entire inventory and all of its detail at one time? Yes, we can. And that's what you're about to see. This will take about 30 seconds to complete. I think we have almost 30 different labels in here. By the way, I'm on a ZPDT, not the fastest IO in the world. I'm 1,500 miles away from it on a hotspot. So I don't exactly have the local connectivity you would likely have if you were running this in your environment. So here's all the labels now and all of their metadata and key attribute information. And you can see that we're highlighting various aspects of this, in this case, stop date, which is critically important. But all the data is here. And so we can scroll down and do what we want to do. Now, we may get to this part right here and we may say, Jesus, you know, stop date, that seems like something important. I'm wondering what all the stop dates are. So we can click on any of the metadata or attributes and click on them. And what we'll do is we'll go off and search in real time and bring back all of the stop dates for all of the key labels that are in the CKDS. And then from here, if we found one that was particularly interesting to us and we said, oh my God, I can't have that thing go out of service, we could click on it. I think we can click on it, click on it, click on it. We would see its particular detail, and then from here we could update it and do essentially whatever we have to do. Okay, so I'm going to go back to my presentation. Hopefully you can see that now at this point. So here's the sum of this whole thing, okay? There are going to be people who are going to get onboarded And you are going to look at them and you are going to say, Jesus, what about this generation? They just seem so shallow to me. Read Nicholas Carr's book. You'll understand what that's really all about. That's your prejudice coming through. That's what you think the world should look like going forward. But they have a completely different view based on the technology that they deal with every day, including their phone. In your world, in my world, and when I say older generation, I mean me, I'm probably older than most of you are. Things are flexible, but they're challenging. We have to dig for information. We went up a steep learning curve. It took years of experience for us to use those tools safely and effectively. It's very impersonal. It has no memory. It doesn't know who I am, and it tends to push back. But when we're on the web, particularly when we're in ICE Direct, things appear to be more structured and simple. There's a given path that we can follow to find the information that we're looking for. It's sort of like breadcrumbs, if you would. We click for information, we don't dig for it. The learning curve is shallow. That is, we can find our way through it relatively quickly and know that it's repeatable. It benefits all of us, particularly beginners. The interaction is personal. In the case of ICE Direct, it always knows who you are and what you have been doing. Regardless of where you've been throughout its entire breadth, it always can bring you back to where you were the last time you reached that entry point. In short, it draws you in and supports you completely. Okay, that brings us to the end. You see my email address down there. If you need anything more, please don't hesitate to email me if you need that script that I talked about that Alicia created that's out on the web. If you need that link, let me know. It's relatively easy for you to set up your own interface to it. If you have the need to generate cipher keys, that's the ticket, man. She did a good job there. Okay, Jamie, I'm done. I want to thank you again for sharing your platform. I really appreciate it. Hopefully, I'll get to come back later on this summer with my friend Charles Mills and talk about the validation of the secure path, the chain of trust, if you would, between your zOS server and any client that might be out on the web. Okay.
Okay, thank you very much, Paul. So we do have a question actually in the chat from Cloda. Hi, Cloda. Say hi to Marie for me, won't you? She says, hi, if you have a data set encrypted in ICSF, I assume that you need a corresponding RACF access control list. And if so, where in RACF is it identified as being an encrypted data set?
Where in RACF is it identified as an encrypted data set?
Yes.
Well, first of all, you could certainly print out the profile of the data set profile itself. Okay, that would be one thing you could do. I think in an APAR, but again in 2.4 and 2.5, there are commands that can be issued, init type commands, I think DSN commit init, that will tell you whether or not a particular data set that's in the catalog has not a profile, but is protected by a CKDS label, okay, whether it's encrypted, and if it is encrypted, what the label is itself.
Okay.
There are ways to get to it, but it's sort of not a direct path, but it's a path where you have to list a profile or use some TSO command to list content of a catalog.
Okay, thank you.
Oh, you're welcome.
I think there was a couple of responses there as well, Cloda, from Mark Nelson and Greg Boyd.
Oh dear. Oh God, no, not them. That's sort of like Darth Vader and Palpatine coming after me.
Yeah, thank you very much for that, Paul. I have to confess, crypto is not my strong point in life, and as some people know, this is why I've got the likes of Greg Boyd and Lenny Bradshaw, and I see Darren Smith there on speed dial.
Yeah.
Should I need them?
All right, let me be clear. What I know about this, I learned from Greg Boyd. Now,
Right.
that doesn't mean I'm the best student on the planet, but I can guarantee you he's the best teacher on the planet, the most patient teacher on the planet. Hats off to him for helping me, for sure.
Absolutely. So thank you very much, Paul. So yes, folks, if you could leave feedback. So I've just posted a link in the chat to take you directly to the feedback page. If you could do that, that would be much appreciated. So we've got a 30-minute break now for afternoon tea, as we would say here in the UK, and we'll be right back at 3:30 UK time. And we have another session with Broadcom with Steve Hosey, who's going to. His session title is "What Just Happened That Compromised Your Mainframe." So it should be very interesting indeed. And I can see Steve there. Hello, Steve. So glad. That's always a good sign when your presenters are around. So hopefully you'll be able to join us for that. And Paul, once again, thank you so much for getting up so early, Paul. I know it's like your breakfast time there. Okay, thanks very much. Take care. Bye.